Okay, good morning, guys. So we're going to continue with what we started yesterday, which is laws of exponents, specifically negative exponents, some zero exponents. And we're going to look at what happens if instead of numerical bases, we have variable bases. And the rules are going to be the same. We just have to do a little bit more thinking if we have more than one variable or a variable with a coefficient, which will make sense once we do it. So let's do a little recap from yesterday. What we'll do now. So 2 to the negative fourth is, of course, 1 divided by 2 to the fourth. And 2 to the fourth is 16, so 1/16. Five to the negative third is 1 divided by 5 to the third. 5 to the third is 125, so 1 divided by 125. Negative 3 in parentheses to the negative fifth. So 1 divided by, in parentheses, negative 3 to the fifth. So we're doing negative 3 times itself 5 times. Now, since we have an odd number of negative, we'd expect our product to be negative. So negative 3 times negative 3 is positive 9, times another negative 3 is negative 27, times another negative 3 is positive 81, times another negative 3 is negative 243. How do we write 136 without the fraction bar? Well, we should know that 36 is 6 squared. So this should be 6 to the negative second, right? Because 6 to the negative second would be 1 divided by 6 to the second. And 6 to the second is 36. Now, what about this? Well, we can do this in a few different ways, right? We can say that 10,000 is 10 to the fourth, so 10 to the negative fourth. But we can also say that it's 100 squared, or to the second power, so we can say 100 to the negative second. And in the same way, we can do number 6 in a few different ways. So I know 81 is 9 squared, so I can say 9 to the negative second. But since 9 is 3 squared, right, 2 9s, each 9 being 2 3s, is the same as 4 powers of 3. So I can also call this 3 to the negative fourth, because 3 to the fourth is also 81, just like 9 squared is 81. So the question becomes, what happens if we have variables, right? So in a basic sense, nothing changes, right? Y to the negative second is going to give us 1 divided by y to the second, or y squared. And p to the 0 power is going to give us 1. Now this is where it gets tricky, all right? So 5x to the negative second power. Now, generally what happens if I ask this question in class is everyone's going to go and they're going to tell me this. Okay, which is wrong. And why is it wrong? Well, there's a lot of reasons why it's wrong. The first reason why it's wrong is the next question I ask is, what is being raised to the negative second power? And someone will raise their hand and say x. I'm going to say 5x, and they're going to say, no, just x. And I'm going to say, okay, great, well, what about 5? And they're going to say, well, the number 5 has a power of 1, right? Any constant has a power, or variable, if there's no power written, has a power of 1, right? Isn't 5 the same as saying 5 to the first? Right? 1 power of 5. So I say, okay, well, if you're telling me that only x is raised to the negative second power, then it doesn't make sense to drop the 5 into the denominator. And then we say, well, what operation is present between these two expressions? And someone will say multiplication. I'll say, great. So I can just as easily express this as 5 times x to the negative second, which means I can rewrite both of these as fractions, right? How do I write a constant as a fraction? We use a denominator of 1. How do I express x to the negative second? Well, we just looked at that. Well, that's 1 divided by x squared. How do we multiply fractions? Multiply the numerator or multiply the denominator? So there's our proof. Okay, it doesn't make sense to put 1 over 5x squared, and that's what a lot of us are going to do, and that's fine. Okay, initially, I understand certainly why students will do that, but it's incorrect. Now, what's different about number 4? Well, this one is going to be like that because we have parentheses, right? Whereas in number 3, I asked the question in class, what's being raised to the negative second power, and somebody says x. If I ask the same question for number 4, what's being raised to the negative fourth, it's the product of 6 and p. It's everything in the parentheses. So this is going to be 1 divided by 6p in parentheses to the fourth, and we don't have to go any further than that, not yet at least. By next week, by the end of the week, we will, but for today we're going to leave it just like that. This is another misconception. 7xy to the 0. If I ask what 7xy to the 0 is, a lot of people are going to say it's 1. And then I'm going to have to walk it back and I'm going to say, what's being raised to the 0? Is 7 being raised to the 0? Is x being raised to the 0? No, just y is raised to the 0. So this is like saying 7 times x times y to the 0. So 7 is just 7, and x is just x, and y to the 0 power is 1, so this is really 7x. So don't make the mistake of saying, oh, I just saw a 0 power, I'm going to say the entire thing is 1. No, right? Only the y is being raised to the 0 power, so only the y to the 0 evaluates as 1. Everything else stays as is. All right, now we have two variables. Same question. What's being raised to the negative seconds power? Just x. Y is being raised to the first, so if we need to rewrite it, y times x to the negative seconds. So what do we know about y? Well, y is a variable, but behaves like a constant when we write it as a fraction in that it's got a denominator of 1, whereas x to the negative second is 1 divided by x squared. Multiply my numerators, multiply my denominators. How about this next one? Okay, well, a to the negative third is 1 divided by a to the third. And b to the fourth, if I need a denominator, I can put it over 1. So we end up with b to the fourth divided by a to the third. Now, I'm hoping at this point, guys, the wheels should start to be turning in our brains, right? I shouldn't have to write this every single time as a fraction. And some of you do, some of you will, okay? Some of us, it's going to make more sense to you to see it as a fraction every time, but we can come up with a shortcut, right? And by a shortcut, I mean we're going to come up with kind of a rule that we're going to use, not something that we're going to memorize, but something that we can apply that we understand. All right? Now, what would we expect to happen for number 9? Well, usually someone says, well, they're both negative exponents, so they both end up in the denominator, and that's exactly right. So a to the negative fourth is 1 divided by a to the fourth. B to the negative sixth is 1 divided by b to the sixth. Multiply numerators, multiply denominators. And we end up with 1 divided by a to the fourth, b to the sixth. How about number 10? Well, let's think about it. The negative 5, we don't care about that it's negative, right? In the sense that it doesn't have a negative exponent. The only negative exponent I see in number 10 is a. So really only a should be in the denominator. So let's break this down piece by piece. I've got negative 5, which has a denominator of 1. I've got a to the negative sixth, which is 1 divided by a to the sixth. And I've got b to the eighth, which has a denominator of 1. So multiply my numerators, multiply my denominators. All right, so we can come up with some pretty good ground rules for what's going to happen to all of our terms. So let's think about it, right? What has happened to my coefficients? Well, in every example that we've seen, they've ended up in the numerator. Number 9, the negative 5 ends up in the numerator. And number 3, the 5 ends up in the numerator. And in number 5, the 7 ends up technically in the numerator because there's no denominator written because it's 1. What happens to positive exponents? And this is something I would absolutely put in my notes. Well, let's take a look. In number 9, there's no positive exponents. In number 10, b to the 8th is positive, that ends up in the numerator. In number 6, the y is positive, that ends up in the numerator. And in number 7, b to the 4th is positive, that ends up in the numerator. All right, I'd say that's pretty reliable. Now this one gets tricky, right? What happens to my negative exponents? All right, so let's look at number 10. A to the negative sixth is my negative exponent. And in the end, I see a to the sixth in the denominator. In number 9, they're both negative, and I see them both in the denominator, but the exponents are positive. With number 7, I've got a to the negative third, and eventually I get a to the third in the denominator. With number 6, I've got x to the negative seconds, and x to the second ends up in the denominator. So my negative exponents will end up in the denominator, but we have to make the exponent positive. And that's basically the rules that we derive from these 10 examples that we've done. Let's put those rules in motion. 7a to the third, b to the negative ninth. Well, my coefficient of 7 should be in my numerator. Positive exponents, I don't have any, but if they did, they'd be in the numerator. And my negative exponents, a to the negative third and b to the ninth, end up in the denominator, but I have to make them positive. So that's it. Let's say we wanted to do number 10 again, using those rules. Well, my negative 5 is a coefficient. That ends up in my numerator. My b to the 8th is a positive exponent. That ends up in my numerator. My a to the negative 6th is my negative exponent. It goes to the denominator, and we make it positive, and we get the same thing we had up here. All right, so these are pretty good guidelines. And again, they're not rules in the sense that I want you to memorize things. They're guidelines that we're going to follow because we were able to derive them by doing all these examples. So again, here's our now try. So you guys, of course, are going to pause. And then we come back. So x to the negative fourth is a nice simple one. 1 divided by x to the fourth. For number 2, we've got 10. So let's do it both ways. Our original way was to split it up. So this is 10 times y to the negative third. So 10, the number 10 has a denominator of 1, whereas y to the negative third is 1 divided by y to the third. So 10 divided by y to the third. But if we would have just used our rules, 10 is my coefficient. Coefficient ends up in my numerator. My negative exponent I make positive, and it goes to the denominator. So those rules work really well. Now number 3 is a bit of an exception, right? The whole thing is raised to the negative third. I don't have to do much. How do I evaluate the negative third power? It's 1 over the third power. Right, so 5xy to the negative third is 1 over 5xy to the third. All right, how about this next one? I want to use my rules. I don't want to write all those fractions. So let's look at my fraction. Okay, my coefficient negative 4 I know ends up in my numerator. X to the 7th, positive exponent, that's easy, ends up in my numerator. Y to the negative seconds, easy, it's a negative exponent. I move it to the denominator and I make the exponent positive. I'll do the same thing for number 5. Let me move it over here. Let's see what's in my denominator. Well, a to the negative second is negative. I'll move that to my denominator, make it positive. B to the negative fourth is a negative exponent. Move it to the denominator, make it positive. Well, I can't have no numerator. So my numerator is 1, right? Because if I broke this down, a to the negative second is 1 divided by a to the second. B to the negative fourth is 1 divided by b to the fourth. And when we multiply, it gives us that. So some of us, guys, the rules may be too much for you. And if that's the case, I want you to just evaluate it each time. Make a fraction out of each expression, and then multiply the fractions at the end. Now, just like yesterday, we're going to do the same thing here. Write the expression without a fraction bar. So we're going to follow the rules backwards. All right? How did something get to the numerator? It was either a coefficient or a positive exponent. How did it get to the denominator? By using a negative exponent. So my numerator's got x squared. So that had to be as is. How did y to the 5th get to the denominator from a negative power? All right. How did the 4 and the x and the 6th get in the numerator? Everything was positive. How did that y to the 3rd get to the denominator? It had to be a negative power, so y to the negative 3rd. And this is kind of like that strange situation that we saw back here with number 3 from our now try. How did this whole thing get to the denominator with the 5th power? Well, we had to have that same whole thing to the negative 5th power. So 3x to the negative 5th power is 1 divided by 3x in parentheses to the 5th power. All right, guys, there's your homework. So 1 through 6 is what we spent most of the period on, just like yesterday, and 7 through 10 is what we did the last couple minutes. Write it without using a fraction bar. All right, guys, as always, questions, comments, concerns, upload your work, post on Google Classroom, and we'll talk about it.